Hey, Hank, how are you doing?
I'm doing okay. And you?
Not too shabby. Still nice in Texas, right?
Surprisingly so. But but still low rain in Austin. I think we're going to turn into a desert.
Oh no. Yeah, I think
Yeah.
the water crisis in Texas is making headlines, right?
Yeah. Yeah, the reservoir that feeds Austin is sitting at like 48%, and we didn't get any rain this winter.
Oh man. Wow.
Yeah. The worry is the fires that could happen in California very, very easily could happen up here in North Austin. The houses are close, just like in California. Wooden fences between all the houses. We will see what
Yeah.
happens.
So which way is Austin expanding nowadays? Is it going more west or is it going? That's where the
I
river comes from. That will
I
make
really
sense.
don't know. The North Austin is, where we have lots of tech. There was a lot of tech in downtown, but I mean,
Yeah. I think everyone has to move out. Downtown is too crowded.
right. I think Facebook or Meta or somebody got rid of 20 floors in one of the skyscrapers down there.
Yeah, downtown should all be converted to UT basically.
Yeah.
But the water is coming from west if that is still coming. I mean, the river is on the west side, so that would
Mhm.
make sense. I don't know.
Yeah.
I was looking at a lot when I was in Austin in Lago Vista, and it was like a quarter acre for 10,000. It's like 200,000 now. Crazy.
Yeah. Yeah. Yeah.
Erin,
Howdy. Who's that, Charlie? Oh, I
this is
missed that.
Yogesh. Charlie is just joining, and
Oh,
Hank is
Yogesh,
here.
sorry.
It's Anil. Hey, Anil. It's Charlie.
Hi,
How are you?
good. How about you?
Good, good. Yeah, the other meeting was still going on, so Drew might join a few minutes later.
There's a GPU meeting.
Yeah.
I see. Yeah, so Anil, as discussed, we'll let Drew wrap up real quick. I sent the agenda also, in like 5 minutes, and then we'll focus on the requirements doc. It's a lot of comments there, as you mentioned.
Yep. If you want, I can start sharing.
Yeah, that's fine. You can. Hey, Varun.
Hey, Yogesh. Hey, everyone.
And maybe set the kind of agenda or framework here. And once Drew joins, then we can fill him up. So this is the document. Yogesh, should I go ahead?
Yeah, I mean, it's up to you. Yeah, we can, or you want to wait another minute or so. Typically, it's up to you. I don't mind. But yeah,
Maybe just let me give a background for those who
Yeah.
joined. So we have been working on this OCP fault management infrastructure requirements. 1.0 was already released, I think last year, or maybe year before. And since then, and that requirement document that we contributed was primarily focusing on out-of-band error handling requirements. And we thought that it'll be good to now work on the next version and incorporate the in-band requirements as well. So this is the document, the version 1.5. It is actually already on our Google Drive. Let's see, where's the drive? I think I'm sharing my screen, right?
Yeah, yeah.
Yeah, so this is the OCP hardware fault management. Within that, there's a work in progress folder. And within that, there's a hardware fault management infrastructure requirements. And this is the document that we are editing. So what we have done so far, incorporated quite a bit of requirements and also kind of merged in-band and out-of-band together. And we are kind of in the process of cleaning up things. And the purpose of today is to kind of review where we are. And then we left at one place or one section that I want to kind of start into that and then start editing that together. So I'll pause here. Has anybody looked at this document? I know some of you have actually. Anyone has a kind of high-level comment, suggestion
When were the last changes made, Anil?
on this document? A few minutes ago.
Oh, then no, I haven't looked at it.
I mean, changes are going on, right? And I think some of the comments, actually, you provided quite a bit of comments, Dean, on the previous version, and I think we have tried to incorporate here, but we might have missed something. So maybe you want to take a look at it and from a fresh eyes, and then add your comments here. Let's see, has Drew joined? Not yet. So it's 6 minutes past. Yogesh, what do you want to do?
Yeah, I think we should proceed. I was just trying to copy link to this doc in the chat window so everyone can open it. Yeah, one request is just to make sure to be in the suggestion mode while changes.
Yeah, I was doing some inserting a diagram, so for that I have to be in
Yeah,
edit mode. Yeah, yep. So I'm in session mode now. Good pointer, good reminder. Okay, Drew is joining. Hey, Drew. He's still joining.
Suke is here.
I got bogged down. Hey, happy Friday, everyone.
All right.
Happy Friday. I think we have the quorum now. I see Meeta, I see Jyotika, Suke, Shubhada, Raj. Yep.
Okay.
Focus group. So we can. Anil, do you want to give Drew like real quick 3-4 minutes here because he's late? He doesn't get 5 anymore, right, Drew?
Oh, that's fine.
That's okay. Drew knows. Drew, this is the one.
No. I'm saying give him a couple of quick minutes to just make a quick announcement.
I see. Sure.
Let me make an announcement. So, okay, so we've been working on kind of, what's next on the RAS API work stream. Yogesh and I, and Shabbat are it's kind of Intel, and I'm the other sponsor, and so we're gonna ramp that up really soon. Your input on CPADs was extremely valuable, and I'm going to be working through the things that people have put in the document. And so we'll continue that discussion. And if we have something we really need to come back and talk about here, that's great. But I think our next proposal is to have the CPAD get further defined in the RAS API group. And we're going to try to get a RAS API spec out quickly that describes protocol for discovering RAS features, configuring RAS features, getting error logs, analyzing errors, and sending actions back. And And what we'll do is we'll take the work there and then build a CPAD that fits into UEFI or ACPI or whatever, wherever else we need. We'll figure out what spec it belongs in and work accordingly. But at this point, I don't think there's any contention that we want to do a CPAD. And if you all have input on the use cases or want to chat with me about it, or if you want to get involved, sign the CLA, join the RAS API work group. And I think that's really all I wanted to say. Is that, do you think I got it right, Yogesh?
Yeah, Drew, thank you very much. I think that's all. Please continue to provide your feedback, reach out, and ping me or Drew if you need the CLA for RAS API work group.
And don't hesitate if you want to talk about concerns or thoughts about CPADs. But we really would like you in the RAS API working. Okay.
Okay. So
thanks, Anil.
Yeah, Anil, please let's come back to this talk.
It was 2 minutes, not even 3.
Right. Anil, you're muted if you're talking.
Yeah, sorry. Are we ready now?
Yes.
Yeah.
Yes.
All right. Yeah, so let's dive deeper into this document. So we have, I think, cleaned up executive summary. I'm going to remove these names now and accept it. And still, anybody has any other comments, please take a look at it and feel free to add comments. We cleaned up the introduction also. There are some few typos and all that I did. So maybe, actually, rather than going through this initial chapter sections, let me just please look at offline. And if you have any other comments to add here, otherwise, in the next review meeting, I will we'll start accepting and then cleaning up in this section. So what I want to do is jump to the section where we left last time.
Yeah, and Anil, we had gone through that initial section like 3 or 4 times.
Yeah.
And you were out part of it, so I think that is pretty well reviewed. So this is good to jump further in.
Yeah, yeah, good. So this is one part of the section that I think we did the edit, but we didn't review it here, I think. So maybe I can would like to start here. So this is part of this section where we are describing the goals. Okay. So within that, we we're calling out like specific goals of the infrastructure. So I'm going to remove this comment from here. So this is not here anymore.
Hey, just one little thing. Specific is kind of an extraneous word. We can say goals to infrastructure.
Sorry, Drew, can I'm having a hard time understanding. Can you say one more time?
Yeah, Drew, I think there's something with your
mic.
audio.
Yeah.
Oh, weird. Okay, I'll try to fix it. I was just saying, oh, I see the problem. Okay, is that any better?
Oh, wow. Makes a huge improvement.
What happens is when I connect to something, it picks a random audio source. I picked up a headset I wasn't even wearing. So I was just saying, it says specific goals of the infrastructure, but specific is kind of extraneous. It's just the goals of the infrastructure, right?
Sure. I'll just accept it for now. Okay. So what we have done here is just kind of bulletized the key things here. The primary theme here is standardization, right? So standardized error monitoring and reporting. Yogesh, you had a comment about this between all hardware components. So I think I fixed it. So what I did here is between platform and management infrastructure.
Yeah. Thanks.
And I also put system here because platform, in the context of platform is a system. Are we okay with that?
Yeah. Okay.
Okay. So yeah, standardizing their monitoring and reporting. Maybe I'll just give a couple of minutes for you to read through, and if it looks okay, then we can continue. If not, then let's talk.
So, Anil, do you want to start accepting these comments and resolve?
Yeah.
Yeah, I think that would be better. So we.
Yeah, let me do that.
There is a typo including what was that? Assessing, is it? Pass.
Oh, sorry, hold on. And then further actions would be initiated, including
Maybe assessing. Oh, passing is probably
passing.
is right. Yeah, it was P was missing. Okay.
Google did a good job. Guessed it. Okay, let's clean this up. There was these bullets were there before, and I see there's some duplication, but it was
Yeah,
okay.
so
Just restating.
I think some of that was rewritten. Mita might remember that. I don't know if she does, but sorry to put you on spot. But some of that was rewritten, and we left the older comments in. We did not
which one was
delete
a
them.
new? Which one was a new?
I think the one on top is new.
No, I think maybe this was new because this is something I edited, and I didn't read through this one, and then when I started reading this one, I said, "Oh, I already wrote this thing here." So,
Okay, I don't remember them.
so yeah, so I think the
Anil,
standardized. Sorry, go ahead.
do you mind increasing the size of the font? Like I can barely see it and I'm on a,
Yeah, I have my windows zoomed up too. That's a good call, Mita.
thanks.
Sure.
Thank you.
Thanks.
Thank you, Anil. You're making it that easier on my old eyes.
Is it better?
Yeah,
Yeah.
thank you.
Okay. So I think this bullet, I have kind of captured here, but again, I mean, please read through this bullet and then over here and see if it meets. If not, I can.
Yeah, the lower one is too specific. It's calling out redfish. And do we want to do that? I mean, there's no harm, but do we really need to do that?
I don't think we need to. I like the top bullet a little bit better.
Okay. Let me clean this up. This bullet is fine. Standardized interfaces for a BMC or hardware component to communicate error actions to an operating system. So basically, what we are saying is, in the case of out of band, right? There should be path from the. And now here we're calling BMC. I think we should really change it to OMA. If that's okay with you, Drew.
I think so. Yeah.
So Anil, one suggestion here, because we are we're talking at the goals level. I don't know if we want to. Do you want to talk in terms of OMA and IMA at this stage, or high level goals are good enough?
No, we already called out here, right?
Okay.
Oh,
all right.
Yeah, I need to fix this diagram. Sorry, I took an action to
But I guess
OMA.
and like actually, so I mean, how do I think of it? Is OMA like a generic term that's broader than BMC?
Yeah, I think that, but Yogesh has a good point. I think OMA is something I introduced over here, right? So BMC is a physical device, and there's a software stack on top of that, the kernel and then the user code and all that, and the OMA. So OMA is a software entity.
Oh, it's not in the glossary.
Yeah, we need to add that. Maybe
And I
So,
think like RAS API, we're not, I thought when you said,
Yeah.
I thought you were talking about a piece of hardware. I don't know if we're going to have a piece of software that really does that. We may have the BMC may be passed through. It just may be like the BMC may just implement a protocol that allows us to talk to the chips.
Yeah, I
Yeah,
think
but you
I
still
also
may,
see.
like, if it is stateful or stateless, you will still need something to transport that, right? True?
Correct.
I think the problem here is we want to define the intent, but when we put something in terms of an agent, what is the definition of that agent? Who defined it? Where does it? Which standard? What is that? It's a kind of a notion of a gateway to that path from the platform, but I don't know if we describe it in terms of an agent, but then leave it there. What does it mean?
Yeah, we're just defining a high level construct here, not the implementation. In the actual implementation, this OMA may not even exist. Maybe it's all absorbed into this user code here. But
Yeah, because
abstracted. Mhm.
yeah. So we already say RAS API, and we say invent plugins, and then
For
we have
example, on this here, right? So when the REST
Yeah.
API calls are made, there has to be some agent that it receives and sends something, right? So same thing over here. When the BMC software stack is either sending something over REST API, is using REST API call, right? So some agent has to be there to actually make the call, right? So at an abstract level, this to me this makes sense, unless someone is saying no, it doesn't make sense. In a very loose term, earlier we were just using BMC as a terminology to just call out this whole thing.
Thing
Yeah,
is,
I guess
will that green box also be part of the hyperscaler infrastructure? I think that it can reside there too, depending on what you want to do. If you want to do everything in BMC or you want to transfer that responsibility to hyperscaler infrastructure, right? I think that it could go out also. That's what I'm seeing. Would you agree, Drew? Like the vendor
yeah.
decoders, for example, like the green.
Yeah. So
I guess
this is not the only vendor code, right? There's a vendor code sitting here also, which I'm not describing here.
I see. Okay. Okay.
Yeah, I think this drawing is aligned with us. I guess, I mean, Shibata, you raised the other point that, you could have like a company that wasn't a hyperscaler might want to do something locally on the BMC,
Mm-hmm.
but they could just show that we just extend that by drawing a chunk of code on the BMC that talks to this RAS plugin, RAS API. So I think we can leave this for now, Anil, but as we dig into the RAS API may end up just being a protocol that gets exposed via Redfish, and there may not be like a block of code. It may just be a Redfish interface that talks to a hook in the plugin, and we're done. But we can leave it for now. We may just roll it back later once we learn more. I just don't know. Let's get a little further with the RAS API, and we can sort that out and clean this up.
Drew, just for what it's worth, I think you're on the right track the first time, because I think that there is kind of a transactional relationship between people that are kind of using the reports and the hardware that it's being reported from. So I think you're correct. I don't think you need to change that to anything else. Just my 2 cents.
Okay.
So Bijan, are you suggesting to make some change here in the verbiage or
No,
in the drawing?
no. I think it's okay, is what I'm saying. I think it's semantically correct. You know what I mean?
Okay. Cool. So this bullet, what I did here is so clarifying the standardization interfaces between BMC and the operating system. And then I added this likewise standardization, standardize the interfaces for the IMA to communicate error actions to the BMC via OMA. But basically both direction, some installation is required.
Sounds good. I mean, conceptually, that is not controversial with me.
Yeah.
You know, I think that makes sense.
Good. Then allows the CSP. I just left these bullets as were there before, and I think that they all make sense. So at a high level, I think this is a good summary of the goals. Let me pause here if anything missing here or some other suggestion. Otherwise, we can move to the next section. And we can always come back, right?
Do we need
Go
to
ahead.
mention that because in a CSP model, you don't want anything on the OS side to interact with BMC, right? So also from an isolation perspective, there would be mechanisms to completely get rid of these interfaces, deployment specific ways.
I don't understand that point entirely. I think like we may pass a message to the BMC that we really intend to the OS for the OS, and the OS could, you know, write a message in the HEST and say, "Hey OS, map this page out," and that'd be okay if we're doing out of band management. And
Right. Most of these interfaces are like memory mapped. So that way there are attack surfaces. I think there are a bunch of papers in this space where you can address in the memory mapped BMC region, and that could corrupt the rest of the memory if you expose that region. So,
I mean,
and
so Amar, because of that security reason, we want to call this out here, right? So if there are API-based interfaces defined or some standard interfaces, then we won't have those kind of issues, because then we will always have to go through the security checks, security reviews and all, right? Today, what the reason that those issues are happening are because there are proprietary interface implementations, and then it opens up all kind of holes.
yeah, like everyone does it differently, and that makes it hard to get right. But if we have a consistent way of doing it, I think it will be easier to make it right. And we'll say, this is the type of thing you can pass along this interface, and that's it.
That's it. Yeah. Exactly. So it'll address those security challenges, right? For example,
Well, I
IPMI.
think there's precedent, right? Because you have like DCSEM and some other things that actually do things exactly like this, right? They lock down that interface. Everything is passed through it, right? So
Yeah. So exactly. Yeah. You're right. Okay. Emma, you're good with that?
sure.
Yeah. Okay. After that, this section, I think we kind of cleaned up quite a bit. One feedback I got from in my one-on-one with Vilas is to call out this feasible versus not feasible terminology. So I added that here, or maybe clarified. It was already there, but I clarified further that this not feasible and feasible concepts or terminology are used from the CSP requirements point of view. Besides that, I think this table has been reviewed multiple times, and I don't see any other comments here added. So I'll continue here. Now this one actually good one. So in the fault class error classification, we called out, correctable error, then fatal reset may be feasible and non-fatal, right? And then we also had this fatal warm reset flow fails, cold reset works, fatal unable to reboot but have power. And the comment was, can we collapse these two or just get rid of this, because this table already covers, in my opinion, these two cases. Let me pause here. Does that make sense?
Can you give us a quick example of what it means that when a warm reset fails but a cold reset works? What kind of scenario is that?
Yeah, so let's go back to this table where we defined these. So the fatal reset feasible. Oh, actually, you good points. We had a fatal reset feasible, And after that, we simply call fatal VR false, which is reset is not feasible. So I think it lumps into the VR false. VR false or BMC VR false. We kind of break it down into two.
Oh, so I don't know if you made it simpler or more complicated for me. What's the difference between cold reset and warm reset for reliability?
Where do you see cold reset here?
I can, if you want, I can speak to it a little bit. So, back in the day when we had really ragingly bad error, processors or teams like HP would do extraordinary things to crawl back out of the error condition. So you go viral and you would like figure out that you were viral. You would crawl out, re-enabling interfaces gingerly and logging errors as you went. And then you would plunge the fabric, which means clear the viral and do all these crazy things to make the system healthy. And then you'd log the errors and build a crash dump that you could write somewhere. And the problem with that was it was brutally hard and it required really inside knowledge of how everything worked. So it was simpler for the industry to just go, hey, we know that we're hosed, we'll just do a reset, but we'll do a warm reset and preserve the error logging registers. And then on the reset, the firmware will see that it was warm reset and go gather stuff. And that's okay. But the problem with warm reset is that in my experience, there's always something else I wish I'd gathered, and it wasn't sticky across the reset. So warm reset has its place, but it has its limits too. And then the next train of thought is, hey, if you can gather something like a crash dump out of band, you just have to say, hold on, everyone, while you gather data via software out of band, and you can gather a little bit more data if you find that you missed something. And so there's warm reset is kind of in that spectrum of how do you handle the really severe errors where you know you need to reset, but you also need to gather some data, but you don't have to do that viral crawl out thing I was talking about at the beginning. So did that help, Dean?
It makes perfect sense, but I don't understand what it's doing here. So there were two cases you basically enumerated. One is you don't crash, you recover. It's an extraordinarily difficult achievement, but you might be able to do it, and you might lose something along the way, but the system doesn't go down. The other one is the system goes down, and you're going to have to reset. Now, whether you warm reset or cold reset because of what you're collecting or what you're not collecting, that seems like below the level of this documentation, or am I wrong? Is this the kind of thing you want to specify?
Yeah, we
I
don't.
understand the difference between cold and warm reset, and I know why you would do one and the other, or both in serial. Does that have a place in this specification?
Yeah, I agree. I don't think so, because those are very implementation specific. As reset feasible category, what we are saying here is that as long as platform can capture their logs, right?
Yeah, exactly. That's what I'm thinking. The requirement is capture the error, and the steps to do that. I'm surprised that it would show up here.
Yeah, I think you're right. I think warm reset is a legitimate implementation choice, but it is not a fundamental requirement.
Yeah, I see your point. Basically, here somebody in previous discussions we call warm reset. I think this category doesn't really make sense, and we didn't even call out this one in our error classification anyway.
So the comment there, collapsing to reset, seems to be a good comment then.
Well, no, hold on before you delete that. So I'm fine with let's truncate warm reset. There is the case. Do we still have the case where we have a fatal error where software can't run reliably on the application cores?
Software cannot run reliably. Are you referring to like
No,
non-fatal?
go back to just where you were, but just one table up.
Yeah.
Okay.
Yeah.
I mean, sorry, it's just the scrolling is a little hard to follow. Okay, reset may be feasible.
So I mean, Drew, certainly there's cases where those kind of errors will occur in real systems. Whether or not, I don't know if they're in the spec, but clearly those things can happen.
Well, we absolutely have. I mean, like, it is a requirement that we can debug things when software crashes and can't make progress, right? I mean, that's just, we got to debug it and fix the machine. So I just want to make sure that use case is covered if we get rid of that line. And I'm not hung up on the warm reset as much as I am just error logging when software can't make progress. But I guess here's the problem.
So that needs to be a requirement in this spec, independent of these tables, right?
Well, no, this it fits into these tables, but this it's a use case. It's one of these, and it talks about, you know, bare metal and infrastructure and application folks have a different situation, um, and it's important, Dean, because we wrote these tables to say, okay, OS first doesn't always work. You know, or firmware first doesn't always work. Sometimes you need out of band. And so crash dump was the common example where things just gunked up, like a sync flood or something. And so I think, Neil, what we need to do is if we're going to take that section out, can you put it back and give someone I'll take the action item, give me a comment, and tell me to rewrite the section to clean up the warm reset stuff. And I don't object to, you know, I agree with you that warm reset is an idea that is an implementation choice, but we need this concept where things are gunked up and we need, like, this is advertising out of band needs to work. And maybe those are all reset may be feasible, but it says warm reset. And if you want to give someone else an action item, but I'm willing to do it.
Yeah, I mean, just to be clear, right? We in the error classification, we didn't call this class of error. We just merged that into this fatal reset feasible, whether it's a warm reset, cold reset. We didn't further classify. If you want to do it, please suggest, and then we can always.
And I don't know that we need a separate case. If you don't mind, though, I would like to take the action item to make sure that the case is covered, that you know, the things are pretty gunked up. And you know, I'm with you, Dean. I'm not pushing back on getting rid of warm reset. You see the case I want to cover, and so as long as it's covered, I'll convince myself that it's covered. We'll be set.
Okay, you got an action item here.
Thank you.
And then fatal unable to reboot but have power. I thought that's the one we're calling the VR faults.
That's where you don't have power.
Okay, hold on. Sorry. Unable to reboot but have power. Oh, I see. Unable
So
to
again,
reboot.
that's the similar case. So the way I see it is, those two are the two that were together are kind of.
So, sorry, Drew. Can you give me an example of this case? I'm not following you.
Yeah, I mean the CPU. Let's say you had a memory, two DIMMs. One DIMM is totally failed, they're interleaved, and you can't uninterleave them, and you can't even. So every time you come, let's say you have one DIMM. I'll give you a stupid example. One DIMM, that DIMM is crappy. It's died. It's generating uncorrected errors. Now, when you try to reboot, you can't use memory and you crash. So you're just dead. You can't come up anymore. And there are other situations inside the processor that I've seen that happen. I mean, it's just, you know, if it's a really hard failure, you can just not be able to come up. But you have power, but you just are so unhealthy you can't boot.
Yeah, we did. By the way, we debated this one, Drew, and finally we kind of merged to saying, okay, let's just put them into, rather than creating yet another category, put in the VR fault category, because the effect is very similar. May not be VR completely failed, right? But something happened that caused some component to fail at a level that.
I think it was we collapsed them into the one above, I thought. So I'll just look at it when I look at this section, if you don't mind. I'll take a look at it, and I don't really care if we collapse them into something. That's great. I just want to make sure the case is thoroughly covered, because
Sure.
we really do have cases where things just can't boot. You know, we crashed and we didn't come back up. That does happen.
And can you please define VR or VR fault somewhere in the document?
Yeah. So
sure.
VR fault is defined in this here, right here.
Yeah.
So VR failed.
Where is it defined?
You mean where VR failed defined?
VR fault. Where does it say what that means?
right here.
Well,
VR
I
failed.
think Dean's saying be more specific. The VR fails
What's
to
a
provide
VR? Virtual reality?
no voltage regulator.
Write it down.
Yeah, so this should go into glossary. So let me just
Well,
add a
I
comment
think
here.
also we could spell out voltage regulator here
Yeah,
too. I mean,
sure. Yeah, add this to glossary. Is that
I
right?
mean, if that's your point, I agree, Dean. We could spell out voltage regulator. That wouldn't hurt.
What is the spelling bug?
Somewhere, yeah. Thank you.
ARY.
ARY, yeah.
ARY.
Sorry. Yeah, spelling
Yeah,
problem.
Dean, if it makes you feel any better, I tripped over this one a couple weeks back.
Well, my memory is so bad, Charlie. I trip over it every time we talk about it. So
Okay,
that's on me. I admit
Yeah.
it, but still, it should be. It
Yeah,
should be
should
expanded.
be.
I think
Yeah.
you can just
Oh.
accept that change too. Voltage, spelling out the word voltage regulator is not, I'm sorry, that is just not controversial.
Yeah.
Hopefully that
Okay.
helps. That's good feedback.
Is that only thing, Dean, or anything else is a
That's
suggestion
all
here?
That's all I saw.
Okay, cool. Thank you. Good call. Yeah, so Drew, let's catch up
Yeah,
on
I'll
these
just
three
make sure. I'll
categories.
just make sure their cases are covered, and I'll let y'all know what I find, and if they're not covered, then I'll propose some wording. But I don't expect this to be a lot. This has been thoroughly discussed.
Yeah, so I'm going to delete my comment because I stand corrected. Let's not remove it, and you have an action to go over this too. Okay. So fatal wear faults, we already reviewed it. Again, take a look at it, and if you find anything else missing or something need to be cleaned up, please add the comments here. Then we did go over solution architecture quite a bit, and I think Mita, you or Shubhadra put these additional definitions, which I think are we reviewed these also, and looks like they look pretty clean to me.
I didn't.
Yeah.
Quick question on the diagram which was there.
Yeah.
I don't know if it's already discussed. Like HSIO, high-speed I/O devices. Is there a link to out of band as well, or probably I didn't see.
Yeah, right here. Can you see that?
Okay. So
Yeah.
So one aspect is like PCIe, for example. There's a kernel-based AER driver. So, and that PCI is considered HSIO.
Yes.
Yeah.
So Amber, what we want to do in that case is be able to mirror that data out of band as well. The OS absolutely needs to see it and react to things going on.
No, actually, one second, Drew. Those, if it's a PCIe device or PCI interface, right? Those errors are propagated to CPU root port, and then from there go to kernel. There's no direct path from HSIO to kernel.
Right. Sure. I guess my point was for out of band. Let's say that PCIe has a problem and the link's down. You may be able to still read what the device's PCI interface thought was going on.
Absolutely. This is one of the major pain points we are going through right now. Yes.
Yes. This is why we need out of band even in your use case sometimes.
Absolutely. No doubt.
Yeah, we're aligned. We're completely aligned.
Yeah. So I don't know who was asking a question. Sorry, Sakul was.
It was me, Amar. Yeah.
Does that answer your question?
Right. And like the outer band flow on the same PCI hierarchy, it also generally goes through the root port as well, right? So
the out of band, well, so the way we are defining out of band here, right, through the BMC. So in that case, there'll be some sort of a separate interface here to the devices.
Yeah, there are two paths. There are two paths. And the way to look at it is that when you plug a piece of silicon in, like let's say you plug in an accelerator, we want that accelerator to be able to express its error logs in band and out of band, and that out of band path can work even when PCIe link is down. But the CPU root port will also report errors from the PCIe hierarchy as well, and we'll see those both in band and out of band permit. So we're just logging on both sides of the PCIe link, and that way, if the link is down, we still get something.
Yeah.
So one
I think
question, this is desired, right? I mean, currently, I mean, if you're looking from vendor perspective, I mean, we have race conditions because there's only one resource, especially with PCIe AER, right? And we avoid the race condition by having that handshake. So here we are adding a requirement saying that there should be out of band visibility, right? It's not how it is today, correct?
That's
I mean,
right, but neither is the RAS API to
Yeah,
be
yeah.
pointed,
Okay.
right?
but there's a difference, right? There's PCIe, that's the interface, and then the endpoint could be a GPU accelerator, and it will have its own set of error registers. So when I see this BMC interface, I see more of those complementary functions that endpoint does rather than per se PCIe.
Oh, no,
Got
but
it.
we do
Yeah, yeah.
both.
You're saying that it should have its own, as a component, it should support both, right?
Yes.
Yeah.
And
it's up to the policy. It's up to the policy, right? How we configure these error flows, right? From
Yeah.
HSIO devices, the PCI errors, in some use cases will configure it to only go through in band, right? In some cases, we may do only out of band.
Or in some cases, we may do both. And
yes, exactly.
And I want to be really clear here. Like if you look at the PCIe hierarchy, the AER registers have to be managed by the OS and the driver. I mean, that's just the way AER works, and we're spitting in the wind if we try to change that. But
if there is a OSC handshake, right?
But we want to see what's going on in the PCIe hierarchy out of band as well. So that if I have a cloud customer that has a bare metal machine and they own the OS and they're yelling at me because of a problem in the PCIe hierarchy, I've also seen the bits. And they can say, I'm not getting these interrupts when things fail. And I can say, yeah, you've got it masked. So we should be able to mirror that information somehow. And to Shibata's point, I know that isn't the case today, but that's kind of the point of the RAS API supporting both in-band and out-of-band, is that both can see it. And maybe and I agree with Anil, there may be a policy that there's one owner, and that owner for AER will generally just be the OS.
Right.
Question about the HSIO to firmware arrow. I mean, so maybe I'm not very clear about it, but it almost seems like thinking about HSIO as PCI Express right now. So for PCI Express to be handled in band by the kernel, you're saying it goes through the root port, therefore the CPU box being linked to the kernel makes sense. But isn't that the same case for PCI Express firmware first handling? It has to go through the CPU?
Yes.
Or the root port, and that's not what's shown on the diagram though.
No. The firm, maybe I think defined firmware somewhere here.
Do we need one firmware box? Do we
so this is the So just to be clear, right? This is the this is a firmware that actually is associated with the device initialization and all that, right? This is not the SMM handler or.
Is this an option ROM?
Yeah, this is kind of option ROM.
Oh, okay. Sorry, I did not I didn't catch that at all. But that makes more sense.
Could we clarify that on the drawing, Anil? I don't think that's controversial to me, but I think Mita's question is good. I was assuming those two firmware boxes were the same thing.
Yeah, that's a good point.
Yeah, let's do this way.
So then what is the black box that encompasses them?
Sorry?
The black box that held both the firmware and the slightly rounded edge black box. What is that?
I think the partition is hardware versus software.
This block, yeah. So exactly. Yeah, this is the sort of firmware software component. This is the physical component or physical part of the component. And the reason I put the same color because they both are associated with each other.
Oh,
But I think color could.
it's not the CPU.
Well,
Sorry?
so we were saying it's option ROM, but I guess so, Neil. There's like multiple firmwares involved with the device, right? There's an option ROM that the host CPU runs to initialize the device. So that's how a graphics card can be brought up by the BIOS, right? But then there's also firmware on the HSO device that plays a role in this too, right? This local, it's embedded in the device like a GPU has firmware.
Right. I mean, I'm defining this firmware as I'm not going too deep here, right? Some sort of a software entity which is associated with the device that provides the interface with the device driver. That's it.
Oh, because that could be on the device too. I mean, like a device driver. Like when I've developed PCI accelerators, right? The accelerator had firmware that talked to the device driver. They passed commands back and forth.
Correct. Exactly. So the device driver is part of the, you can call, OS domain running on top of the kernel. And this firmware is associated with some sort of EEPROM sitting on the device.
So can we just make that box say device firmware?
Yeah, that's a good point.
It's a little tight. I hate that. I hate that. Yeah, but at least that'll be super clear. Now I know that is firmware that's associated with the HSIO device.
Yeah,
I'm
I
still
think that's
confused as to what the black box is. I thought the black box was the SoC or host or CPU or whatever you want to call it. Now you're saying it's not?
Are you referring to this black box, George?
Yes, yes.
It was just easier to kind of see things. These are all the software components, software firmware component. This is the actual hardware component. Same thing here also.
BMC should also be out of that.
Yeah. I think somebody made the comment and I forgot to change that.
Yeah, you can just move the bottom of the box up too.
Yeah.
Conservation of effort.
But the kernel BMC is in there. Okay. It's a strange organization I've never seen before.
The kernel, the reason I put BMC here is because there's a kernel here also, there's a kernel here also, so we wanted to kind of distinguish.
Yeah,
there was a lot of debate on that.
No, the BMC has a kernel. I mean, every BMC I've ever seen had some sort of kernel it was running.
Exactly.
It may not be Linux, but it was some kernel.
Yes.
And in between these black boxes, do we need that arrow? Because there's already underlying arrow with CPU and devices from the BMC.
So this is the one that we were referring earlier, right? That from again, I'm not calling this any specific here, but in-band agent, for example, right? Need a way to communicate to the out-of-band software. And likewise, from out-of-band, need to communicate to the in-band.
Like let's say that I send a CPAD to the out-of-band management agent where I want the OS. I've predicted that memory is going to fail, and I want to tell the kernel to get out of that memory. I'm running some special memory vendor analyzer. What I would do is send the message to the out-of-band management agent. That vendor code would somehow put something in ACPI visible space, and then tickle ACPI to copy that into the host so that the kernel goes, oh, I've got a page I should mark bad, and marks it bad.
But that's the link between CPU and BMC, right? Through which it's going. There's no.
Well, this is a software. I guess we're just making the point that the software can pass messages.
Like for example, the XID's GPU push out to out of band, that also goes through the device driver in a way. So
well, XIDs don't really fit this. XIDs are kind of bad. They're counters. They're not CPERs. They're not rich. So I mean, sure, but they're not a great example. They're an example of kind of what we don't want.
But let's finish that thought pause, right? And good point. You're saying XIDs which are reported to the kernel, right? To the kernel?
No, XID is reported to out of band. They firstly go to the device driver and then get pushed out to the BMC.
The device driver collect the information and then sending a message to BMC using XID kind of semantics?
Maybe
Yeah,
I'm the
yeah.
only one, but what is XID?
I have no idea.
It's a counter from an NVIDIA GPU.
Okay.
That's like
Uh,
CPER, equivalent of CPER.
No, it
No,
is
no,
not.
no.
It is
No,
a counter. It is not CPER. CPER should have a lot of data. XID
I
does
mean,
not have a lot of data.
it's not a counter, it's an error event.
It doesn't have
yeah,
much.
it just a ID to X, which is any kind of event, and their constructs are through the device driver to the kernel. That's it. Device driver to the kernel, spits out on the console.
So it
If that's
has
what,
both like the version we are looking at here, it has both in-band and out-of-band way.
no,
So if
so Emma, we're getting an implementation here. The information with the context of XID is saved somewhere in the EEPROM, and then it spits out to the kernel, and PM out of band can also read that, and that reading happens out of band. Okay, there is no this. We don't use this or at least again.
right.
I don't want to go too deep here.
Got it. Yeah.
Okay.
Yeah.
It's a
I
very
think-
implementation thing.
Well, and I think that a lot of what we're doing here is trying to remedy problems caused by
Yeah.
that kind of error. It is not. I would not hold that up as what we want.
Well, anyway, let's not go there. Yeah, it's a implementation which has its own challenges, but they're good times also. So let's keep it here as a very generic, concepts. Any other comment here or question? Ambiguity? Dean, is there question answer now the intent of this box, or do you suggest anything else?
Yeah.
Here it is actually.
It's not
I did
labeled, but
have-
I understand it's okay.
Okay, and I did have a question about this. So we talk about direct attached memory over here. So I mean, we do we. I mean, we don't anticipate like CXL over here,
Well, that would be a
which is
high
not
speed
direct
IO.
attached.
Yeah, there'll be a device, yeah.
Or
Now,
HSI devices.
but you have a good point though, because if you talk about type 3 devices, sorry, type 1 devices, right? There, the notion is it's not directly attached, but directly accessible memory.
Well, it is directly accessible, but there should be a memory controller
Yeah,
that reflects error logs up to the device driver and out of band.
correct.
To the out of band. So it's just another silicon device that happens to have memory on it. It's not.
Yeah, so yeah, some of these nuances are not very obvious here, and it for right reason, because we if you want to draw each and every scenario, right, then this drawing becomes too complex.
But we could mention it. I think it's a fair question. We can just like we put a little bit of text in the document somewhere. It says where you describe HSIO devices. Can we just say it could even be a CXL memory?
Yeah, in fact, there is okay, I think we missed, let me add that here. First of all, before I forget, let's add a
Good.
device firmware here.
Yeah. Thank you. That's all. That's a
And,
good addition.
yeah, and then, so this is adding two, and then we'll add the definition, or someone want to volunteer, please add definition here. Text here.
But do we need to call out device firmware? Like it's just part of the device,
yeah,
how
the idea,
device does things, right? Like
no, the idea here is to define this terminology that we are using in the block diagram.
It was in that picture, so we just need to make the picture clear, right?
okay.
Yeah, yeah. And then let's directly attached memory.
That kind of goes up in the upper heading, right? The CPU and MEM and HSIO.
Oh, yeah, it's there. Okay, sorry, I missed it. CPU, MEM, oh, I see. We just club them together because these are all hardware component, right? So maybe we should just clarify here, right? This memory is a directly attached memory, and there could be other type of memories in the system, right?
Well, I guess I would like to make a more general statement that we want this architecture to work for any kind of add-on silicon. So whether it's, you know, a GPU, a video transcoder, a, you know, zip unzip accelerator, a you know, CXL memory device, a smart NIC. I mean, you know, just any of these things should, if they're attached via high-speed I/O, they should be able to give CPERs out to us.
Yeah.
Right. I mean, like it just doesn't matter what it is. We want the same kind of interfaces for anything.
Yeah, I
And,
Yeah.
agree.
Good coil could also be implemented as part of I/O, for example, CXL type 1 device. Does that make sense?
well, I guess I was going to say, you know, HSIO devices should all be loggable this way, including CXL type 1 memory, smart NICs, GPUs, you know, whatever accelerator. It just doesn't matter. It's just another piece of silicon that has error handling interfaces.
Do you want me to add something here, Drew?
Yeah, I mean, well, I can add it. I just want to put the list of, yeah, like I don't think that the,
HSIO device could be,
well, I would
example,
say any IO HSIO device, including GPUs, you know, smart NICs, video accelerators, you know, should have interfaces that work, you know, in the manner described in this spec.
later, CXL. What else you said, sorry? Yeah, NICs.
Video, smart NICs, video accelerators, you know, just anything. It just doesn't matter. It should
I shall have.
interfaces that, so you know, that work according to the spec or something. You know, I don't know how you want to word it, but you see what I'm saying. It's like these aren't special. They have RAS features. We can configure them. We get error logs from them. We analyze those error logs and we drive RAS actions back to them. You know, let's not.
Yeah, I think we're just defining it, right? So HSI devices could be GPU,
Or more.
etc.
Yeah, I mean, including implied and incomplete list.
Could be, yeah.
That's why we
Could
had
be
it.
any high speed interface based device.
And then you say including these.
Yeah.
And that way we're just saying it's not a complete list, but we want to jog people's thinking and say, hey, you know, this should generally work. And then and drives, and these devices. Oh, yeah, that sounds good. If you just do that, I'm happy. You know,
Yeah.
I just want to get it through to people that, you know, any silicon you put down has the same general needs if you step back far enough. And if we and then they don't need special plumbing, we should be able to build plumbing that works for them.
All right, folks, good point to stop. We are a couple of minutes over. Let's continue here next week. Okay.
Why
Yeah,
don't we stop
I
in 2 minutes?
just want to kind of queue up for the next meeting that this is the section I added today. So please take a look at it. This is in alignment with some of the discussion we had in the past. And then I build up the in-band drawing, which is the Drew's drawing with the simplified version. And then I kind of said, okay, now this is the overall, which include in-band, out-of-band both together. So that's how I'm structuring this section.
Sounds good. Thank you, Anil.
Thank you.
Cool.
All right, folks. Have a wonderful weekend. See you all next week.
You
Thanks,
too.
bye.
All right.
Thank you.